All right, so let's do an example that we're more familiar with. Let's figure out if f of x equals x squared minus x. Let's come up with,
It's x cubed.
let's find formula for the derivative, f prime of x. Okay? It's x cubed. You think the answer is going to be x cubed?
No, the f of x equals x.
Oh, it is in the thing? Oh, okay, that makes me unhappy. All right, f of x equals x cubed minus x. So which definition do you want to use? You want to go h?
I like it.
You do?
I like it.
You have to do all that nasty stuff with H.
Yeah, with h you have to plug that in there and then cube it.
Yeah, that's fine though, because I memorized it.
Because you got the Pascal C now?
We can't all be close together and memorize everything. Let's go with H.
We can do that. And I got the thingy.
What are we doing?
Let's do
Wow.
let's do a and see if that works. I don't know at this point. I don't know. Yeah. So f of x is x cubed minus x.
See, yeah, you can't do it.
Minus f of a is a cubed minus a, all over x minus a.
We have to see if it factors into something.
I don't know what a is. Now that we're coming up for a formula for the derivative, a is just going to be a. So if they tell you find the value of the derivative at x equals 5, then a is 5. But if they say find a formula for f prime of x, then a is just a.
Okay.
Okay? All right, so yeah, we need to factor this top thing into x minus a times something, right? So let's cheat and do a little synthetic division. We know a is going to be a factor, okay? So this is x cubed, so that's a 1.
Hold on.
0, because there's no x squared, so you have to have a 0 in there.
Oh, yeah.
Okay, and then the x term is coefficient is minus 1, and then the constant coefficient, I'm going to distribute that negative sign through there. It's going to be negative a cubed less u plus a. Okay,
That's all one.
these are the coefficient. Yeah, this is all 1. So that doesn't have an x thing at the end, so that's going to be our constant coefficient. Hold on, I'm waiting for Gabe to get it straightened out with Donovan. Yeah? You guys? Okay. All right. Okay, so bring the 1 down. A times 1 is just A. It's what?
Oh, just go on.
Okay. A times A is, oh, I'm sorry, 0 plus A is A. A times A is A squared. A squared plus negative 1 is a squared minus 1. And then a times that is a cubed minus a. So those cancel and give me 0. Okay? So that means, truly, honestly, synthetic division is one of my favorite math things in the world.
Alright.
And it's a little bit scary because I really don't understand why it actually works. It's totally awesome. Okay, so we start with an x cubed. So that means this is going to be x squared plus ax, right? Plus a squared minus 1 all over x minus a. How I got this from this? Okay, the highest power here was, you got it?
I think that's why I like H, so I don't have to use synthetic.
Okay, well you gotta get past that.
You don't like synthetic?
Synthetic division is like,
No.
it's even better than difference of 2 squares. I started with an x cubed, right? So this is going to be my x squared, my x, and my norm. If I started with x to the 4th, this would be x to the 3rd, x squared, x norm.
So if that was 1 and make 2x squared.
Yeah. Okay. Okay, and so now that we, come on back, come on back, come on back.
Oh, I've made those before, they're gross. Yeah.
Again, try the other gross.
Okay, now that we have factored this, the x minus a's cancel. And then what do I do to figure out the limit? Plug in an a, so this becomes a squared plus this becomes a squared plus this becomes a squared minus 1. So altogether, what do I have?
3a squared.
3a squared
Minus 1.
minus 1. But we want a formula for f prime of x, so not to freak you out or anything, but you should be writing your answers as 3x squared minus 1 instead of a. Same thing, same thing. They want the independent variable to be x, not a. You don't need to do that. Okay?
You just put a in and then you put x back in.
Yeah.
Alright.
So really, you could get to here and put in x's instead of a's if you wanted to. Save that stuff.
Too much.
Too much? Too far?
Hold up.
Assignment?
You're funny.
Assignment?
You are funny.
You look expect us to do all these parts.
Why wouldn't I? Okay, so let's graph the
We
original
actually have
function.
lives.
well- So our original one was x cubed minus x.
There's only like 3 people in here.
So
who
far,
don't have anything to do.
Are we less lazy than last year's class?
Not particularly.
Really?
Okay, so there are our 2 graphs, and I'm going to change the window so we can see a little bit better what's going on. It looks like most of the stuff is happening between -3 and 3, so I'm going to change my x minimum to be -3 and my x maximum to be 3. And then look again, we don't necessarily have to do this, but they just kind of wanted us to, again, make this connection between the derivative and the original graph. Yeah, let's zoom in on our y's a little bit, huh? How about 1, 2, 3, 4? I put in the original function, x cubed minus x, and then the derivative, 3x squared minus 1. Okay?
What does it mean when they intersect? Is there anything special happening?
Do they
Not
intersect?
necessarily.
That's x
No.
equals 0.
Not
Not x
necessarily.
equals 0, y equals 0.
That just means that the value of the equation is the same as the slope of the tangent line gave. That just means the value of the equation is the same as the slope of the tangent line, but there's not really a relationship there. Okay. All right. So what we're seeing here, let me do one more thing, and you guys with the cool calculators can make these, or they already are, different colors. Let me go. So the original function is this. The bold function is the derivative. Okay. So hopefully you can see the connection between what we did before. Here the slope of the tangent line is 0, so the derivative crosses at 0. Same thing over here, the slope of the tangent line is 0, so the graph of the derivative crosses at 0. Here the equation is increasing, so what does that mean about the graph of the derivative? It's going to be positive, which means it's above the x-axis, okay? Then here, in between this point and this point, the graph is decreasing, so it's below, but it has to come back to 0, okay? So it goes negative, and then it comes back around, and then from here on out, the graph is increasing, and so the derivative is above the x-axis also, okay? So, once again, kind of see that same connection between the graph and the derivative that you should be building in your head. And again, the key points are, where is the derivative 0, where is it increasing, and where is it decreasing? That's what we would like to kind of jump out a little bit, okay? All right, so let's do another one. Let's find, if f of x is the square root of x, let's find f prime of x again. Okay? And yes, this isn't a good one because of the square roots.
Now we're gonna like go home thinking that we know this.
And we're gonna
And you're going to be proved correct.
wrong.
Okay, so let's just switch things up a little bit, just to keep us
On our toes.
on your toes. Yeah, let's do the h for this one. So the limit as h approaches 0 of f of what?
A.
X plus h. So that's our y value minus f of x. That would be our y1, and then this is going to be over h. Okay? So the nice thing with using the h definition here is that we don't really have to do any algebra to get started, because what is f of x plus h in this case?
The square root of it.
Square root of x plus h. Minus, what's f of x?
The square root of x.
Square root of x. And so that part was easy, but there will always be some pain in there. How am I going to simplify this in order to get some things to cancel?
Conjugate.
Do what now? Multiply by the complex conjugate. Only that girl hasn't left us. Because the complex means there's square roots in there.
Okay, will you hold on?
How can I hold on real fast? What do you mean, will I hold on real slow? If I hold on real fast, and now I'm done holding on and I'm ready to
Yeah.
This is probably like a simple question, but why did we just make it f of x plus h is the square root of x?
because we took the x plus h and plugged it in for the x in the original. Okay? So just like we wanted to avoid doing that on the last one because it was x cubed, and we would have to plug it in and then cube it. It's the same thing here. We're just taking it and plugging it in for that. Okay? Substitute, sorry. I don't. You know what I'm saying. Whatever. All right, so if you FOIL these out, again, the beauty of the complex conjugate is that these two things will multiply together to give us x plus h. The inside and the outside cancel, and then the last times the last is minus x. And then as previously stated, never distribute on the bottom, because, right, we need stuff to cancel.
Yeah.
Okay? And in fact, things do. This x and that x cancels, giving us with just an h on top. And then the h's cancel, solving our 0 problem. We do the limit as h approaches 0. Don't forget there's a 1 there still. When the h is canceled, h divided by h is 1. So cancel ever makes it 0.
Yay.
Okay, and so now we can substitute 0 in there for the h. And so that'll give me 1 over the square root of x plus the square root of x. And what's the square root of x plus the square root of x?
2 square root.
2 square root of x. So my answer is 1 over 2 times the square root of x. All right? So we're just playing the same game that we did before, except that we are trying to find the actual function instead of the value. So we're plugging in, substituting in for that. All right, so we're having so much fun. Why should we stop?
No, we should.
All right, we did a regular old polynomial, and we did a square root. Now let's do a rational function so we can see how all of these go. Okay? For my money, personally, in my own experience, if it's a polynomial, I want to stay away from the h thing, because then you have to plug in the x plus h and do all those powers. Okay? But any other thing besides that, the h is usually a pretty good way to go. So for this one here, I'm going to use the h.
You can do it.
just said to say what.
From the polynomial.
Did I say it backwards? Okay, if it's a polynomial, I don't like using the h, because, you know, you end up having to raise x plus h to some high power, and I mean, it's not bad if you have the thing memorized, but yeah, you get a really long, crazy thing, and so I'm not a fan of that. But anything besides that, the x plus h isn't such a bad way to go. But you could do it with a's on this also, and it would still work out. All right, so f of x plus h is what? 1 minus, well, because this isn't a polynomial, this is a rational function.
Yeah, so, well, before you said rational functions, don't use a.
Oh, I meant with polynomials.
Oh, I understand.
Sorry. Okay, so that's,
I still.
so f of x plus h is 1 minus x plus h over 2 plus x plus h, right? So that's easy to substitute in there. That's okay. That's what I'm here.
How you got that from f of x plus h?
Same, that's the same question you asked about the square root thingy, is that I just took these x's and changed them into x plus h's.
Okay.
Okay? That's always going to be my first step. Okay?
Oh, so that's all on top of it. Yeah.
Right.
I thought you were like.
Yeah, not
done.
even, no.
Yeah,
This
that's
is
what
over
I
h
thought
and I
was
still
the,
have a
like,
minus.
the-
Gotcha. Okay, no, got a ways to go here yet. All right. Maybe this was a bad decision to go with x plus h. Things are not looking good right now. That's too late. Gone down this road. What's f of x then? That. Okay, so that's going to be 1 minus x over 2 plus x. This is terrible. Yeah. Should we bail and just?
That's it.
Okay.
No.
Abort!
No.
Yeah, we said it's too hard, we're gonna do.
All you have to do is copy.
Why don't we just do that first one?
All you have to do is copy the report.
Jefferson. Okay,
Oh,
he
yeah,
said let's
for real,
support the
they
whole
just-
year.
We just graduated.
Did they do the eight?
So yeah, and then 8.
All right.
They did eight?
Yeah.
Okay, well, I don't know, maybe this won't be any
I
better.
feel like the first day probably doesn't work now, though.
Okay, so let's try again with the A definition. So f of x is,
Hold on, you're gonna wait because now that's how I write all this.
it's going to be the same. We abandoned ship, swam to shore, now we're going to do the A thing. But it's better because before we had like 3 terms on the bottom and that was going to get gross. This is not great either. Yeah, because we do have to get a common denominator on top. And what is my common denominator going to be? 2 plus x times 2 plus a. Okay? So since I multiplied this 2 plus x by 2 plus a, I have to multiply the top by the same thing. Gabe?
Well, like, I don't know, in real world, I get messed up, like, what do you do first? Like, is PEMDAS still a real thing?
MDOS is still a real thing. All math rules still apply.
But, like, how do you know to find a common denominator?
Because when you were in advanced algebra and you did a chapter on rational functions, you were taught how to simplify rational functions by getting common denominators.
So, like, you could just right off the bat, like, multiply by, x minus a.
You could. You want to multiply by the reciprocal? You could. But that's going to be, you'll end up still having to get a common denominator.
So lights
So
just
that's-
flickered.
That would
God, we're all gonna die.
I thought
So that would make your life even worse.
Help us, you two. The government.
Gabe, generally speaking, before you do that, you condense it into one fraction over one fraction. Okay? So if I have 2 fractions over one fraction like this, I gotta straighten this out before I start messing with those. Okay? Alright, so my common denominator is 2 plus x times 2 plus a. And then again, since I multiplied the denominator here by 2 plus a, I have to multiply the numerator by that also. Minus, this is going to be 1 minus a times 2 plus x. So this is turning out to be just pretty gross, no matter how you do it.
What is that one?
This is 2 plus a.
2 plus 8.
Looks like 2 or 9.
I know it looks silly, but it looks different, but you shouldn't have to ask that question because you should know what it is
I was just
by the
making
context
sure
of the
because I
problem.
can multiply that. I understand.
Okay, all right. Okay, so let's boil out these top things now.
Wait, why would you do that?
Why would I do what?
Never mind. Do your thing.
Just go. All right, so if I FOIL out 1 minus x times 2 plus a, I get 2
Plus
plus
A.
a, because that's the outside, good, minus 2x is the inside,
Minus XA.
minus xa is the last.
Minus.
Okay, minus, and remember that this negative sign is going to carry through to all of the terms that we're about to get, so I'm going to keep those in parentheses, okay? 2 plus x minus 2a minus ax, okay? And that's sort of a joy to the world moment because there's a lot of things that are going to cancel. Do you want me to FOIL out the bottom too, or just leave it alone?
Leave it.
Leave it? For now, we'll just
Well,
leave
let's
it.
boil it.
Too late.
Just want to watch the world.
Okay? And then that's all over x minus a over 1. Okay? So, since the negative carries through here, 2's cancel. The negative xa and the negative ax cancels. And that's about all we got there. So that's not a bunch of joy to the world, but we can combine some like terms here. A minus negative 2a is 3a. And then minus 2x minus another x is minus 3x. Okay? Over 2 plus x times 2 plus a over x minus a over 1. All right? So now we're good. You can see the end where it's where.
Boil the bottom.
Okay. I am going to invert and multiply. I'm going to factor 3 out of the top to make that 3 times a minus x over 2 plus x times 2.
Yeah, make it negative 3.
Okay, good idea. Negative 3. Right, so it'll be
X minus A.
x minus a, yeah. Because Pua, this a was positive and now it becomes negative, and this x was negative and now it becomes positive. Okay? And the reason why we did that is because Connor and Leanne can see the end of the story. We want it to match up with that x minus a, right? So that now these can cancel. Alright?
Oh, good lord, that was.
And then now you can plug in a for all the x's, but I'm going to plug in x for all the a's.
Oh gosh.
So 2 plus x squared, negative 3 over 2 plus x squared. All right? Jerry, how do you feel about that?
I'm confused about the last step, like the
Yeah, me too.
I took this and flipped it over.
the X minus A.
Uh-huh.
So x minus a is
Became 1 over x minus a. And so this x minus a and this x minus a cancel.
because you change that 3a minus 3x.
Yeah.
That's,
Yeah.
that's the bottom.
Okay, so that's
And then once you did all that,
E A is 3X.
No, I just said if I make,
Combine them.
if I make this into 2 plus x times 2 plus x, by just substituting,
Oh, we put in the
then
x.
that's, yeah, put in the x, no, it's just 2 plus x, yeah, 2 plus x.
Okay, I understand that, but why is it? Just because we're just like on the formula?
Yeah. Okay. Okay, so I had that thing up there at the beginning, the little background, and you guys said, what is that? Notate, what is that? Almost done. Just going to share some notation with you and read you a little bit of the history. Okay, so we've been doing this. F prime of x, right?
Right,
Well, you all know that f of x and y are the same thing, right?
right.
So f prime of x is the same as y prime, okay? You can also do, and we're going to use all of these, dy dx. And where that comes from is we're really finding the slope of a tangent line, correct? And slope is the change in y over the change in x, right? And sometimes in science class you write it as delta y divided by delta x. So that's why it's dy dx. It's delta y over delta x. But then, once again, since y and f are basically the same, you could say df dx. Or sometimes that's awkward because you're like, well, it's not f, it's f of x. So then you say, all right, then what you got going is this. Take the derivative of f of x, which is what that background on my computer, that's the notation that they were using. Okay? Yeah, they were sort of stylized
I
D's
thought
a
it was
little
like
bit.
backwards 6.
And then we will rarely ever see this, but you can also have capital D of f of x, or this like that. I don't ever really see that. Okay. Leibniz was the dy dx guy, and Newton was the f prime guy. And so here, well, you're going to have to do both. And it says in your little history lesson on the side there, it gives you some stuff about Leibniz, because we don't know him as well as Newton. But it says, unfortunately, a dreadful priority dispute, meaning who did it first, who did it prior to the other one, arose in the 1690s between the followers of Newton and those of Leibniz as to who had invented calculus first. And I would quibble with the word invented and say discovered, but that's a philosophical question. Leibniz was even accused of plagiarism by members of the Royal Society in England, because of course Newton was from England, so they were backing his up. The truth is that each man invented calculus independently. Newton arrived at his version of calculus first, but because of his fear of controversy, did not publish it immediately. So Leibniz's 1684 account of calculus was the first to be published.
And then you made it more controversial by starting with fighting.
True. But, you know, what are you going to do?